Hello everyone, welcome back to Pre-algebra with Miss Betsy. Today we're going to be talking about how we find the area of a circle, and because I'm doing this specific for a certain specific pre-algebra class, I am not going to take the time to go into the explanation of how they derive the formula for the area of a circle. It's really an interesting little illustration that they use, and I'm standing here trying to go ahead and get into lecture without even telling you what I'm doing. I use as my text Pre-algebra for Christian Schools. It's published by Bob Jones University Press. I'm using the first edition. I am today working in section 12.3 on page 409, which is called Area of Circles. You don't have to use that same text. I've picked up a lot of you have subscribed to my channel, even though I don't even know where you're at, because it doesn't matter what text you use, you're going to find the area of circles the same way. I'm not going to go into the neat little picture of how they actually come up with the formula to find the area of a circle. You could Google something on the internet or look in other text to see how they use the circumference of a circle to come up with sort of like a parallelogram, which you can find the area with, but it's the understanding and comprehension of that really is somewhat beyond a pre-algebra class. So I'm just going to go ahead and give you the formula and show you how to plug in numbers for that, so that you have an actual way an actual concrete way that you can actually find the area of a circle when you need to do so. But before we jump into that, our lame joke for today is, I'm on a streak of really lame ones. And this one says, what lights up a soccer stadium? A soccer match. So let me fix this lighting so it's slightly better, not greatly better. And we're going to go ahead and dive right into this by simply showing you the formula for the area of a circle. First, we have some other circle formulas though that are good to review very quickly because they use this weird creature known as pi. And pi is a letter in the Greek alphabet, and when you move on up further in your math studies or in science, they're not going to use an estimation for pi. They're just going to use this figure here. But in pre-algebra, certainly in pre-algebra, we're going to say that the value of pi is approximately equal to 3.14. And the reason we say that it is approximately equal to 3.14 is because pi is what we call an irrational number. That means you cannot write it as, when you do the division, when you try to put it into fractional form, it's what we call a non-terminating, non-repeating decimal. So the value of pi goes on infinitely with the decimal values here. It's actually 3.141592683, I think. People have calculated, well, a computer can calculate from now until Jesus comes, and we're never going to figure out the exact value of pi. So that's why we just say that pi is equal to approximately 3.14. And that's what you're going to use to calculate the area of a circle. But before I tell you how you find the area of a circle, I also wanted to tell you how to find the circumference of a circle. The circumference of a circle is pi times the diameter. The circumference of a circle can also be calculated if you only know the radius, and that is 2 times pi times the radius. A little bit of circle diameter, circumference vocabulary that we are going to be using here. Diameter, radius, and also chord. Let me show you that right quickly. We have a circle. We have the center point. The radius of a circle is from any point on the outer part of the circle to the center of the circle. That's called the radius. A chord is a line segment that goes from any one point on the circle to the other part of the circle. That's called a chord. Now, if you have a specific chord, specific definition here, and that's one that passes through the center of the circle, from one point on the circle to the other side, passing through the center of the circle. That's called the diameter. The circumference of a circle is the distance around the circle. And the reason that we have two different formulas that we can use here, pi times the diameter and 2 times pi times the radius, is because what is a diameter? A diameter is the same as 2 radii. It's not radiuses, it's radii. Let me go ahead and write that vocabulary word for you, radii. It has 2 i's, R-A-D-I-I. So a diameter is the same as 2 times the radius. So to find the circumference, if you're given the diameter, pi times the diameter. If you're given the radius, 2 times pi times the radius. Now, what we're talking about in this section is how do you find the area of a circle. And we learned in our last section when we were talking about area is square units, and it's the number of squares that it takes to fill up a particular area. We would see that this is 12 square units. How in the world can you have squares out of a circle? Well, you know, you don't have squares, you have these curved pieces in here. And the fact that you can't visually see perfect squares, that's where the whole concept of this pi comes in, of 3.14. So, the formula to find the area of a circle, or how many square units would fit inside that circle, is pi times the radius of the circle used as a factor twice. Our area of a circle is pi r squared. Okay, all you have to do in this case then is plug in your values to calculate the area of a circle. So this says find the area of each circle. Use 3.14 for pi, round to the nearest thousandth. So first, our problem, this is example 1, and this is on page 410. The radius is equal to 4 centimeters. Area, remember, is always square units, so the area of our circle here is going to be in square centimeters. Always write your formula for me. Area is equal to pi r squared. Don't start plugging in, don't think, okay, 4 squared is 16. Write your formula first. And then do your substitution. The area is equal to the value of pi, which we are saying is approximately 3.14. Your problem tells you use 3.14 for the value of pi, times r, which is 4 centimeters, and we square that. So the area is equal to 3.14 times 16. Hand calculate that, or use your calculator, and that is going to give you a value of 50.24. Now, is that our answer here? No. It's area, square units, 50.24 centimeters squared, square centimeters. Now, there's one little thing that I've done not specifically correctly here. Do you see what it is? It has to do with this equal sign. And it has to do with the fact that we've used pi here. And you'll notice that in your book, where pi doesn't have an exact value of 3.14. Only God knows the exact value of pi. Nobody does, because we calculate forever. get the fastest supercomputer in the world, and it's going to calculate until it burns up, and the next generation burns up, and the next generation burns up. You cannot come up with an exact value of pi, so you cannot come up with the exact area of a circle. So we say that the area is approximately equal to. Remember that the way the equal sign means is approximately equal to. Our instructions had told us to round to the nearest thousandth. This is 2400ths. Why didn't we round to the thousandth? Well, because this one multiplies out exactly. So when it multiplies out exactly, you don't just tack an extra 0 on. So the area of a circle with a radius of 4 centimeters is 50.24 square centimeters. Now, let's look at our last example that I want to do here. And this one has a diameter of 2.4. Read your problems carefully. Example number 1 has a radius of 4 centimeters, so that gave us an area of approximately 50.24 square centimeters. Example 2 says D is equal to 2.4 centimeters. D is equal to 2.4 centimeters. Write your formula. Your formula tells you that the area of a circle is pi times the radius squared. Now we're going to go ahead and substitute our values in. We've been told that pi is equal to 3.14. Now what are we going to substitute in here for r? Look at this. They didn't give you r. They did not give you the radius. They gave you d, which is diameter. They want you, they're thinking, okay, they're not paying attention. They're just getting numbers. This is not times 2.4 squared, is it? What is diameter? Diameter is twice the radius, so you have to divide this diameter in half. So it's actually 1.2 squared. Okay? 12 times 12 is 144. So the area is equal to 3.14 times 1.44. Okay, now when you do your multiplication, it comes out to 4.5216. 4.5216. You get used to writing equals. It's not equals. Remember, we're approximating the value. So just like you're going to want to think, oh, that means radius, and it doesn't. You're also going to want to put equals. Well, the area is approximately equal to 4.5. I think I didn't write something right. 4.5216 centimeters squared. Is this our correct answer yet? Go back to your problem and see. Your problem says, find the area of each circle, use 3.14 for pi, an approximation. Then it says, round to the nearest thousandth. Is this rounded to the nearest thousandths? Tenths, hundredths, thousandths, 10 thousandths. So in order for your answer to be exactly correct, you have to round this. So we have the area of this second circle is approximately 4.522 square centimeters. You have a lot going on with these problems. You have to make sure you get your formulas correct. You have to make sure that you're getting the right values that you are substituting in. So that's the end of how we find the area of a circle. Let me go back at the end of this video, since it's such a short one, and it's the end of our particular grouping of homework for my local class here in Texas, and see what have we done. We've said that the area of a rectangle was equal to the length times the width. Then we talked about a parallelogram. And what did we say a parallelogram was? It's a rectangle that's leaning. Two pairs of parallel sides. And you have a base and a height. So the area of a parallelogram is the base times the height. And then we said, what is the area of a triangle? We saw how if you took a parallelogram rectangle, turned it into a parallelogram, cut it into two congruent triangles, that the area of a triangle is half the area of a parallelogram. 1/2 the base times the height. And then we talked about a trapezoid. Trapezoid is similar to a parallelogram, except a parallelogram has two pairs of parallel sides. A trapezoid only has one pair. Remember, a trapezoid sort of looks like this. You have two bases, and we did some construction there. We took one parallelogram, turned it upside, one trapezoid, turned it upside down, attached it together, saw that we had a parallelogram, saw that the base was actually the sum of these two bases to come up with this formula that I said, even if you don't understand where it came from, you have to memorize the formula for a parallelogram, which says, you have to memorize the formula of a trapezoid, which says that the area is 1/2 the sum of the bases times the height. Rectangle, parallelogram, triangle, trapezoid. What did we talk about today? We talked about the area of a circle. Let me see. Where's my hand? I can actually fit this. The area of a circle was our other geometric shape, and the area of a circle is pi times the radius squared. Get all of these area formulas memorized. You cannot come up with the answer unless you know the formula. Okay? Shoot me a text if you're stuck, and I'll see you next time.